also the same as for and while loops, functions can be incompleted. So for example, you want to write a kind of function that is incomplete and you want other developers to develop it, or later you want to get back to it and develop it, but you want it to exist so that you do not forget it. You can write def incomplete, and you don't have to name it incomplete, okay? It's just here for practice I'm writing it. So incomplete, and you can write pass so that you won't face any error, but keep the functions in order to get back to it later in the future. So we have pass for functions as well. And also here, let me save this one. And if you call this function, you will get nothing. As you can see, we have the previous prints, but we have nothing about the incomplete and also no error. And the next thing that we want to get familiar with the functions is one of the mathematical operation of the functions, and that is recursion. So we have recursive functions, and with recursive functions you can run the functions for a number of times or up to infinity. By using the recursive functions, you can, if you assign a number as an input of the function, you can rerun the function inside the function. So for example, you get the value of k inside of the function, and then you call the function from inside of the function with k minus 1. I need to write an example for you, but this was the explanation of a recursive function. If you have studied mathematics or in your high school or any part of your education, you know what a recursive function is. You're going to understand this one very well. But don't worry if you haven't heard of it. We're going to completely explain all of the details of a recursive function. So here I'm going to paste in the function that I've written, because here I need to first write the function and it's going to take some time, and then I'm going to explain it line by line. So here is the function. We have the recursive function and it gets the value k, and so I fixed this one because the variable was a different one. So here we have the recursive function, and this function, what it does is to, for example, it gets k as 6. So so we want to get 6, and once it gets it, it does multiply it with the numbers from 0 to 6. So for example, 5 multiplied 6 multiplied by 5, by 4, by 3, by 2, and multiplied by 1. And it doesn't do it for 0, it only does it for the numbers that are greater than 0 and less than the number that we've given to the function. So for example, if it's 5, it's equal to 5 multiplied by 4, multiplied by 3, multiplied by 2, and then 1. And it does the same for 4. Is going to multiply all of the numbers from 4 to 0 and not the 0 itself, and so on. So what this recursive function does is to do the same thing that we want. So for example, once we give it a 6, it will first check if the number is greater than 0, and if that holds, it's going to multiply 6 by the recursive function for 5, and so it calls the function for 5, it enters this function and checks, so it's greater than 0, it's going to multiply 5, and then 5 is going to be multiplied by 4, it gets inside this function with 4, and then 4 is going to be multiplied by 3 and 2 and 1, and once it gets to 0, because it's not greater than 0, it will return the resultant 0 and says input is equal or less than 0. So a number of times this function is going to be printed out, and it's going to work and do this stuff for us until it gets to this 0 here, and it will not multiply 0 by all of the numbers, and once it gets to 1, it will print the result, and then it will multiply the number with all of the ones from the recursive functions 2, 3, 4, 5, and 6. So here let's test the functions by writing recursive function, and inside of it I can write, for example, 6. And here, as you can see, it should also return the result as well. So here I fixed the function and converted 0 to 1, because it's going to return 1, and if it's 0, it's going to multiply all of the numbers by 0, because it's the last result it enters. So here, if I save the code and run it, here, as you can see, first it got to this printing input is equal or less than 0. Then it will return 1, because this is the last function that we get to with using the recursive functions, and then it will get 1, then multiplied by 2, multiplied by 3, it gets 6, and then multiply 6 with 4, gets 24, and multiplied by 5, it gets 120, and then multiplied by 6, it becomes 720. And you can do it for any number that you like. For example, if I do it for 10, it will be very much greater number. As you can see, we have a huge number, 3,628,800. So this is a very useful method for recursive functions, for implementing them, and it's very useful.